Last lesson we started looking at inequalities. Today we will be solving inequalities. So the good news is that solving an inequality, you're finding the value for the variable, except there's more than one value. So it's very much like solving an equation. So for example, let's take that. For example, we'll start with a nice easy one. M minus 9 is less than 2. There's an inequality. We need to find what are the possible values that m could be. And here's the thing that's different from an equation. In an equation, we'd get m equals and we'd have one number. Here, we're going to have a whole range of answers. The good news is you solve it exactly the same way you would as if this were an equal sign. Instead of an equal sign, we have an inequality sign. But we do the same thing. We want to get the m by itself. How would I do it with an equation? I would do the opposite. So guess what? That's all we do here. We get m is less than 11. Now, here's something that is different from when it's an equal sign. If this were m equals 11, you could just put 11 in your answer blank. If you just put 11 on this, it's wrong. Can m equal 11? 11 is less than 11. So 11 itself doesn't even work. But also there's a whole bunch of numbers. What could m be? If m is less than 11, what value could it be? Diego. 10. What else? Vincent. 9. Jim. What's that? 2. Roland. 0. Negative a million. Negative 1.5. Negative 1.4. Negative 1.3. There's an endless amount of answers. But it's not 11. 11 is not an answer that works. 11 is not less than 11. So here's one thing that's important on this. For your answer, either boxing on your homework or to put it in the answer blank on the test, if you don't have the entire phrase, m is less than 11, then it's wrong. If you just write 11, that's wrong. If this were an equal sign, you could write m equals 11, or you could just say 11, because that's the only answer. But here, of course, it's an infinite number of answers. Now, if you are asked to graph your solution, and I believe, yes, the instructions on the homework do say to graph the solution, number line. Now, you don't need to give me an endless number line. I need the number that's in the solution and at least one on either side of it. Notice I'm not going all the way to 0. I don't want to go 0 all the way up to 11. I don't need that much of the number line. The part I need has 11. I want to see one number that's bigger and one number that's smaller. So for example, you didn't even need the 9. You could just have 10, 11, and 12. So you don't need a full-size number line. Just show me the part of the answer. Now, m is less than 11. Since that does not include 11, we would do, remember, an open circle on the 11. That says not 11, but now everything less. Now, is there going to be an endpoint as I put my arrow to the left, or my line to the left? Will it ever end? Good, no. We could go into infinity in the negative direction. So all we do is we put an arrow on the end of that line, and that shows this keeps going. There's no endpoint. M has an infinite amount of numbers that could be the solution, and they're all less than 11. Okay, now, there is one thing that's different. Let me do some blue. One thing that's different about solving inequalities from equations, not just the graph and the inequality sign, but the main thing that you need to pay attention to. If you multiply or divide, only multiplying or dividing, if you multiply or divide by a negative number, now this means you are multiplying or dividing, not that just that there's a negative number in the problem, but that as you are solving it, you are either multiplying or dividing by a negative number. Flip the direction of the inequality sign. And this is an important difference. And I can show you why on the next problem. I'll show you why we have to flip it. If you multiply or divide by a negative number, flip the direction of the inequality sign. For example, negative 8k is less than or equal to 16. In order to solve this, think about what we did on the last one. What am I going to do on this one? It's just like we would solve it if it had an equal sign. What would I do to solve this one? Luke? Yeah, this is being multiplied by negative 8, so I do the opposite. I divide. Now, we are dividing by a negative here. Oops, negative 8. When I say you multiply or divide, I mean the action that you take is multiplying or dividing by a negative. Before I continue with my problem, I'm going to stop and I'm going to flip the direction of the inequality sign. That's a negative 8, by the way, just a little sloppy. Before you continue, as soon as you realize you are doing either multiplication or division by a negative, you flip the direction. Now I just continue with the problem. K is greater than or equal to negative 2. Now, it has to do with the negatives, and if you picture the negative part of a number line, the fact that the numbers, although the digit gets bigger, 3 is a bigger digit than 2, the value of negative 3 is less. Now again, you don't even need this much of the number line. If you wanted to show negative 2, negative 1, and negative 3, that's fine. K is greater than or equal to negative 2. Greater than or equal to, okay, or equal to tells me it's a solid circle because it includes the negative 2. Greater than are all the values that go to the right. And if you're not sure about flipping the sign, why we do it, it's kind of a long explanation why, but it has to do with the fact that the bigger digits are actually a smaller value on the negative number line. If we pick a number that's not on our graph, so for example, I see negative 3 here. It's not on my pink graph, meaning it's not a solution. Test it out. What if we plugged in negative 3 where the k is? Look what would happen. A negative times a negative 3 would make positive 24. Positive 24 is less than or equal to 16. That doesn't work. Negative 8 times negative 1, positive 8 is less than or equal to 16. That is true. So if you test some out, you'll see that they don't work. But if we hadn't flipped the sign, don't do this, this is wrong. If we had left it like this, k is less than or equal to negative 2, we would have our graph going this direction. And I just showed you negative 3 doesn't work. We would be showing all the wrong answers. So this is not accurate. Okay, you have to flip the sign. And it's an easy thing to forget. So be on the lookout for that. Okay, I'm just going to show you one or two more examples. You're going to treat these, for the most part, except for this rule, you're going to treat these just like you would if it had an equal sign instead of an inequality. So, for example, 6x minus 3 is less than 7 plus 4x. If this were an equal sign, I would tell you have to get both sets of variables on the same side. We have x's on both sides. We need to get them all together. So we're going to do the same thing. I'm going to move my 4x group because it's smaller, and that will help me avoid negatives. Here's one place you really want to try to avoid negatives, because if you end up having to multiply or divide by a negative, then you have to remember to flip the sign. So 4x, those disappear. 6x minus 4x leaves 2x. I still have minus 3 is less than 7. We solve it the same way as if it had an equal sign. We'll leave the x's alone. We'll start by undoing the minus 3 by doing the opposite. So we're doing those inverse operations. 2x is less than 10. I'm not quite done. Don't leave it as 2x. I don't want to know 2x, I want to know x. So divide both sides by 2. X is less than 5. And to graph that, we'd have an open circle at 5, less than, all the numbers to the left, 4, 3, 2, 1, 0, all the way down to the negatives and beyond. So you will be graphing each of your answers. I'm going to show you one more problem, and then we'll get to, I'm going to show you what no solution or infinite solutions would look like. So we'll just do one more example here. Let's put a bunch of stuff together. 2 times w minus 8 in parentheses plus 9 is greater than or equal to 3 times 4 minus w in parentheses minus 4. It's just more stuff. You guys know how to do each of these steps. We'll do the distributive property. We'll move our variables all to one side. So this is all stuff we've done with equal signs. The only difference, inequality sign. So we just have to think about doing the same steps, but being careful if we multiply or divide by a negative number. Let's start by distributing each of these coefficients outside the parentheses. I get 2w minus 16. And on the right side, I get 12 minus 3w and then minus 4. Next step, let's just simplify. Before we move anything, is there anything on the left side that I can combine? Any like terms? Pammy?
Negative 16 plus 9.
Yeah, negative 16 plus 9. The 2w doesn't change. Negative 16 plus 9, negative or minus 7. How about on the right side? What like terms can I combine? Rebecca?
12 and negative 1.
Good. 12 and minus 4 or negative 4 makes 8. And I still have minus 3w. So that was just an extra step of distributing and combining like terms before we move anything around. Now, just like on the last one, I've got variables on both sides and I need to get them all together. I've been saying all along, try to move the smaller one. Which of these two is smaller? Carissa?
Negative 3.
Good. If you look at the sign, negative 3 is less than 2. And here's where you might really want to do this. If we move the 2 instead, and we say minus 2w, we'll end up with negative 5w. We have a negative 5 we're going to have to end up dividing by, which means we'd end up having to flip the inequality sign, that extra step, which means one more thing that you might forget. So if we look at the sign, negative 3w is less than positive 2, so let's start by moving this. And by avoiding a negative, maybe we can avoid one little mistake that could give us the wrong answer. 2 plus 3 is 5w minus 7 less than or equal to 8. At this point, I think you guys all know what to do. We leave the w alone. We start with the minus 7, and we do the opposite, which is plus 7. That gives me 5w is greater than or equal to 15. I divide both sides by 3. I'm sorry, by 3. Whoops, by 5. I was giving the answer. We wouldn't divide by 3. 5 divided by 3 would not help us. 5 divided by 5 helps us. That gives 1w. And then our answer is 3. And if you graph that, it would be a solid circle because of the or equal to. Greater than 3, it would go to the right in the greater than direction. Now, just a couple things I want to point out while you are solving, some situations that you might see show up. In fact, let me just show you the graph of this one real quick, and I'll use this one as an example of what I'm going to talk about. 2, 3, 4. Again, just doing the number that's in the solution and at least one on either side. Solid circle, greater than 3. Okay, everybody's good on that graph matches this answer, right? Everybody can agree with me, hopefully. Greater than or equal to, solid circle, greater than. What if your answer had the variable on the other side? Is this statement that I wrote here in pink the same as this one in brown, or is it different in terms of what the answers would be? This one says 3 is less than or equal to our answers. What do you think? Vincent, same or different? The same. He is correct. Look at what happened. When the variable is on the other side, notice that the inequality has also changed. If we say 3 is less than w, what numbers could fit? 4, 5, 6. 3 is less than 2? Oh no. 3 is less than 4? Yes. So you need to make sure that it matches up. Notice in both cases, remember it opens up to the bigger one, right? Like the alligator when you first learned this when you were little. Here, it's opening to the w. The w is bigger. Here, it's also opening to the w. The w is bigger. So if you get an answer that looks like this and it's hard for you to understand exactly what the graph should look like, flip it around. But make sure that you flip the direction of the inequality also so that if it's opening up to the w, it still opens up to the W. Okay, because if it's easier to graph this way, you can flip it. You just have to flip the sign with it. Now, last thing, if you see you get everything and the variables all drop out and you get a statement that is not true. Is 0 greater than 8? Okay, good. Some of you didn't answer, but I think you will say no. This is not true. If you get a not true statement, this means no solution. And so this is just like before with the equal sign. If you get a statement, all the variables drop out, and you get something that is not true, like 0 is greater than 8, then that means no solution. If you get something that is true, so again, all the variables drop out, let's say it says 8 is greater than 0. Well, that's true. But there's no variables. This means infinite solutions. If you are asked to graph an infinite solution, I'd say give me just a couple pieces on the number line, and guess what your graph shows? Everything. An arrow in both directions, everything. I don't need circles, every single thing is included. If the variables drop out and you have a true statement left, infinite solutions, your graph is just the whole number line. And not true, no solution, if you get that, you don't need to graph it. You know, put a number line and mark nothing on it, might as well not even bother. No solution. Okay, that's it.